You have been using functions since your very first line of Python. Every time you called max or abs or len, you were quietly using a function that someone else already wrote for you. Today, you stop simply borrowing them and you start building your own. Look at three functions you already know. Max takes in two inputs and gives back the larger of the two. Give it 3 and 7 and it hands back 7. Abs, the absolute value function, takes in a single number and gives back its absolute value. Give it -5 and it returns 5. Len takes in a string and gives back how many characters that string contains. Give it the word hello and it returns 5. Notice the shape all three share. Something goes in and one answer comes back. That is what a function is, a named piece of code that takes inputs and produces an output. Here is the quietly powerful part. When you call len, you have no idea how it actually counts the characters, and you do not need to. The inner workings are hidden away. This is abstraction. The function hides exactly how it does its job and shows you only a simple relationship, inputs going in, an output coming back. But that raises a question. If the how is hidden, how does anyone know how to use it? The answer is the specification, also called the docstring. The docstring is a contract written by the person who creates the function for the person who wants to use it. That user might be a stranger, or it might simply be you, 6 months from now having forgotten how your own code works. The contract answers three questions. First, what are the inputs? For the length function, the input is a string. Second, what does the function actually do? And third, what is the output, the value it gives back to whoever called it? Inputs, behavior, output. Nail those three, and you have written a good specification. You have almost certainly seen a docstring already without noticing. Start typing a call to abs in your editor or hover your cursor over it, and a little box pops up. It shows the signature. Abs takes one input named x, the value you want the absolute value of, and it shows a line of description. Return the absolute value of the argument. That tiny pop-up is the contract. It tells you the input, what the function does, and what it gives back, without ever revealing how. That is the whole point. You can use abs perfectly while knowing nothing about how it is built. Two things about this contract surprise people. First, the docstring is nothing magical. It is literally just a multi-line comment, plain text describing the function. There is no special syntax to memorize. The second surprise is bigger. Python does not enforce the contract at all. If your docstring promises that the function handles both positive and negative numbers, Python will not check that for you. It is entirely on you, the writer, to make sure the function actually does what its specification claims. The contract is a promise between humans, not a rule the language guarantees. So why go to all this trouble? Because functions let you tame large programs. Once you have written a few, you hold a collection of small tools, each one taking some input, doing a single useful task, and handing back an output. Now look at a big sprawling file of code. Search it for pieces that repeat, the same handful of lines appearing again and again. Every repeat is a clue. It is telling you that this chunk of work deserves to be pulled out, given a name, and turned into a function you can reuse instead of copying and pasting. This is how you break a huge program into pieces. You carve it into small self-contained modules, each a function that does one job well, and then the main body of your program changes character entirely. Instead of one giant wall of instructions, it becomes a short conductor. Ask this module for an answer, ask that module for another, then combine the results. The messy details live inside the functions. The main code just coordinates them. That is decomposition, the same idea that lets many separate parts build one working whole. To use functions, you have to shift how you picture code running. Until now, a Python file has run straight down the page, top to bottom, one line after another, and every line executed the moment it was reached. Defining a function breaks that habit. When you write out a function definition, that block of code has exactly one job: to tell Python that this function now exists. And here is the part that trips up almost everyone. Defining a function does not run it. Not a single line inside the function executes at definition time. Defining says to Python, here is a useful piece of code, ready and waiting, but it stays asleep until you call it. That gap is exactly what makes functions so powerful. You write the code one single time, then call it 100 different times. Later in your program, each call with different inputs producing different outputs. One definition, endless reuse. Think about writing a whole file of code. Typing those lines does not run them. Nothing happens until you press the run button. A function works the very same way. Writing the definition does not run it. You have to call it to make it go. So what exactly are you building when you write a function? Every function you will ever write has the same four parts: a name, a set of inputs, a docstring, and a body. Let us look at all four together on a single skeleton, so you know what belongs where before you write your very first one. Here is the anatomy of a function. First, the name. Just like a variable that stores a value you want to reuse, the name is a handle you use to refer to this whole chunk of code. Here the name is square. Second, the parameters, also called arguments, the inputs. They sit in the parentheses right after the name. A function can take 0 inputs, one or many. This one takes a single input. And third, the docstring, the specification we just met, a multi-line comment stating the inputs, what the function does, and what it returns. Fourth, the body, ordinary Python code, exactly the kind you have been writing all along. The one new rule is how it ends. When the function has finished its work and computed its final value, it hands that value back using the return keyword. Step back and you have the whole idea of a function. It is a reusable named piece of code. Inputs go in and output comes back, and the docstring spells out that contract for whoever uses it. Defining a function only tells Python that it exists. It does nothing until you call it, and one definition can serve 100 calls. And every function is built from the same four parts: a name, its parameters, a docstring, and a body that ends by returning a value. Next, you will write one of your own. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.